All right, so 1.6 is solving compound inequalities. So compound means you have more than one inequality. There's more than one things that it depends on, more than one constraint. So inequalities containing and. So a compound inequality containing and is only true when all parts of the are true. The graph is the intersection, aka the overlap of the graphs of each of the inequalities. So this is literally we're talking about where they overlap. So both of them have to be true. When considering two inequalities together, such as w is greater than or equal to 4 and w is less than 9, they both have to be true at the same time. Because I have the word and, they must both be true. So this first one, this is what w is greater than or equal to 4 looks like. The second one is where w is less than 9. So notice we have an open circle because it's not an or equal to. So they both have to be true at the same time. So what we're doing is we're looking for the overlap. So literally, this is the portion where they overlap, and you see that's what's highlighted below. Just the overlap portion. So the way you could figure this out, so you know w is greater than or equal to 4, so you put your hole there and you put a little arrow, and then I say w is less than 9, so put a little open circle and go this way, and then I see, okay, they're facing the same way, I can connect them. Sometimes your and, you'll end up with only one arrow, because it's like, oh, if w is greater than 4, and if w is greater than 6, okay, well, cool, they go the same way. Right, but the only intersection would be the greater than 6. So that's a different example. But you're only looking for where they exactly overlap. So let's go ahead and let's do this first example. Graph the solutions and graph the solution set on the graphs provided. So this example A, we're looking for where they overlap. So A is greater than 5. So A is greater than 5. So and it's also not an or equal to. Since A is greater than 5, I put a little open circle. And I know it goes this way. And A is less than 0. So I put an open circle here. And I put my arrow that way. Wait, and they both have to be true. So we're looking at where they overlap. Where do they overlap? They don't. Where do? Yeah, so they don't. So what's the solution? Exactly. No solution. All right, let's try the next one. So, this one, it's written differently. So you can say -1 is less than x and x is less than or equal to 6. Or you could say -1 is less than x, which is less than or equal to 6. So this is how you would write an and with two inequalities at the same time. Okay, so let's see where they overlap. So first, I have -1 is less than x. So if I wanted to rewrite this, this is the same thing as x is greater than -1. Right, -1, if -1 is smaller than x, that means x has to be bigger than -1. Okay, and our second inequality is x is less than or equal to 6. So I split it up into two inequalities. I have the variable on the left side, so we don't have to think as much. I can just have the variable on the left side, and then the arrow of the inequality shows me which way to point. So x is greater than -1, so I put a whole little circle, -1, and I put the arrow going that way. Maybe it's easier if I do it like that. And then we have x is less than or equal to 6. So at 6, I have a filled circle. And less than means it's going to be pointing that way. Oh, coolio. They're pointing the same way. So I know the solution is literally going to be connecting them. So I have an open circle on the left side and a closed on the right side. So this is the portion where I have my solution. All right. Questions so far? We okay? Hoping this is like jogging the old memory, getting those webs out of your brain. And if you're like, wait, what? There's plenty of notes in the previous explaining inequalities. So example 2, solve each compound inequality and graph the solution set. So here's two examples. Shall we have two people come up and do them for participation points? All right. I saw, eeny, meeny, who hasn't done it yet? Dylan Bookbinder! Woo! And let's have Talia. Here we go. Dylan and Talia. Okay. Cool. Just do it here. Awesome. So
right?
here, solving, we have to, so you have to get the k by itself first. Beautiful. Here's this one.
Oh.
Cool. Go ahead, Jack, on the line. Oh yeah, it's on that. It's clear.
Did I do it right?
Yeah. Alright, let's see. So k is greater than 5. So you have an open circle, goes to the right. K is less than 9, open circle goes to the left. And the solution is the part that's between them. Perfect. Yep, it's literally just that part. Right, sorry, it's made difficult. Just move it up for you a little bit.
Subtract the 7 from the 2.
Exactly.
Minus that. And then here too.
Yep. On
Why not
all
the
3 parts.
Oh, even the 6?
Yeah. So if you want to get rid of it here, you have to subtract it on all 3 parts. Because what you do to one side, you have to do the other. Well, here we have more than one side. Awesome. One more.
Yes.
No, that was last lesson. That was right on the bus. Maybe going longer. Perfect. Exactly. All right, so let's double check. Are we all good with this? Let's do a little, I'll just do a little review. I won't move you. Oh, you're highlighting the color? Perfect. Yeah. So okay, I've had the same question. I just want to make sure we're all clear, especially because I'm screencasting this for Elizabeth or Isabella. So Dylan came up and he has the open circle at 5, open circle at 9, and then you're connecting them. So some people were doing something like this where they draw the arrow this way, and then they have the other guy and draw it that way, and you could like shade in between to really show where the solution is. That's fine. Another example is, let's see, so here Talia put the closed circle, -1, beautiful, and so you could draw the arrow going this way, and then we have a closed, open circle right here because it's not or equal to at 3. And it goes the other way. So someone asked me, is it okay if they just highlight the center portion? So literally just pointing out that this is the part that's the solution. That's also fine. Okay, those are and. So notice our solutions for and are just a segment. It's literally a line segment. Versus or, a compound inequality containing or is true if one or more of the inequalities is true. Either one, it doesn't have to be both. They could both be true, but it doesn't have to be both. So it's the union of the 2 inequalities. So an example is, I'll email your parents if you get below a 70 or you get above a 90, right? Because if you get above a 90, awesome. I'll be like, hey, your kid's a boss. Look at him go. Look at her go. How to ace this. Oh my gosh. And if it's below 70, I could say, well, hey, I'm here to help. Let's figure this out. Let's not like let this continue. So that's my or. So notice people between a 70 and 90, oh, you're chilling, okay, cool, you could get increased, but I'm not going to spend time emailing every single person's parent. So that's like my or. So if it's like above here or below, that's like when you'll get some contact. So that's an example of an or. On the freeway, on the 405, you could get a ticket if, are you going above the speed limit? Or if you're going below the minimum. If you're going 20 miles an hour on the 405 when everyone else is going 70, a lot of interstates have a minimum that you have to go because it's dangerous. You can't go 20 when people are going 80. So you can get a ticket if you're going above the speed limit or if you're going below the minimum. So notice it's like at 2 intersections if you're either side of the correct miles per hour. So that's an example of an or. We can go through this inequality. Okay, so we have to isolate the a, get it by itself. So I have a less than 3. Or I have, let's see, add 1 on both sides. I have a greater than or equal to 4. So once again, I'm going to go over to the right side. A less than 3, so I have an open circle at 3. Open circle at 3. And it will go this direction. And then I have a closed circle at 4, and it's greater than. So that's perfectly acceptable. So the way I drew arrows, I know some of you guys do that because that's what you learned. Another way I draw the arrows is I literally, I will draw the open circle and then I'll just like go this way. Closed. Maybe not necessarily on the number line, but like tick marks so you can see where it goes. There's like many ways. I just want you to make sure you have the open or closed circle at the correct number and then the arrow going the right way. That's what I care about. All right, what do we say we get more people up here doing participation points? Eh? Okay, let's have Ashton do this one and Elizabeth do this one. Cool. All right, just be careful of the red because I'm screencasting.
Right. So, do this one.
Okay,
9. Just, okay.
Oops.
So, 2 is equal to x, right? Or no, not equal. This one. And did the no sign did not change.
You can erase with the right, the back of it if you need to. Make it all clear. Okay, you have a question?
8, 2. And then this one stays the same.
I thought you ran out.
So 9, positive 9, and it is dark. And then we got this one 2, and this one is open. And then this is negative, is x is smaller, so it goes this way. And then this one, the x is also smaller, so it goes this way.
So what would the solution be?
The solution would be not all real numbers because this part is, or no, it would be from 9 lower.
Exactly, because this is an or. Only one of them have to be true. So if I picked a number like x equals 6 and I plugged it in, well,
So
if I plugged
would
it
be
in here, 6 is not less than 2, but 6 is less than 9. So only one have to be true. Since this x is less than 2 totally is overlapped by the fact that x is less than or equal to 9, the only solution for this that we would write is just the x is less than or equal to 9. Awesome, thank you. So literally the solution for this one, just to be clear, because we have this overlap, right, we see this guy is being overlapped by this one, only one had to be true, so I'm going to take the one that's more broad. All right, so the solution is just going to be x is less than or equal to 9. All right, Elizabeth. All right, Talia, you want to sit up, please? Along.
Alright.
Alright, so, ask you following here.
I'm gonna lose it. 100%.
Well, your choice. Either you can pick the phone over there, and I'll remind you to take it, or I can take one to the station, and then we can have a conversation. You can have a conversation while you're doing it. I'll remind you at the end. Cool.
Wait.
Alright, so if you haven't already tried, try this problem. We'll double check with this. I want you to try, if you're done, try example 4A. I'm gonna go through the rest of the problems since this is taking
Yeah.
Alright, let's see. So you subtract 1, so it's 12 divided by 3 is 4. Awesome. And then z is less than 1, so z less than or equal to 1, so you have a dot, and then z less than 4. Okay, cool. So what's the actual solution? Just z is less than 4. Awesome. Since it's an or, We want the one that's more general because it's not facing the opposite ways. So
Why is it? Is it the Z one, not the one?
and so z is less than or equal to 1. Okay, so the z less than or equal to 1 covers this guy.
Which one is gonna be? Z's going over.
Yeah, so the one right here, z is less than 4, also covers all the ones that are covered by z is less than or equal to 1. And since this is an or,
So can we choose either one?
no, because we need the one that will fit. So I need, okay. If I pick a number like 4, right? 4 is inside my green highlighted. It's not inside the yellow. So it's not inside the z is less than or equal to 1, but it's inside the, shoot, was that 4? I'm sorry, if I pick a number like 3, if I pick 3, so I'm going to pick this number right here. So it should work. So 3 is less than 4, that's check, but 3 is not less than or equal to 1, that's not right. But since we have an or, only 1 has to be true for our solution. And since every number right here is covered by the one that goes this way, I can pick the more general one.
How is Z less than or equal to 1 not right?
It's inside the z is less than 4, because every single number that fits z is equal less than or equal to 1 also fits the z is less than 4.
It's not wrong, is what she's saying. It's just.
It's inside the
smaller.
other one.
The other one is more.
Just like this,
Yeah.
the one that Ashton did right here. Every number that fits the solution in pink is also covered by the solution that I highlighted in green. So I don't have to write both. I only have to write the one that actually fits all my numbers. So this is the case when they are overlapping, but instead like A I had to write both because they're literally no overlap. Is that your? Yeah. So ors can totally overlap, and you pick the one that covers all of them, or or they don't overlap at all, and you have to write both. So either they overlap, and you pick the one that covers more, or they're going opposite directions, and you have to like write both. Versus ands, guess what? Ands, you only have the part where they're overlapping. Because if you plug in a solution right here, like if I'd plug in 7, it would have to fit both inequalities. Versus here, if I would pick 7, it only has to fit 1. So an or only has to be true for one of them and have to be true for both. So when you look at a graph, you can tell what the solution more or less will be by looking. So this first one, I see they're going opposite directions. What will this be? What type of graph will this be? Do you need to go? Okay. So there's a screencast so you can look at the notes. So just to tell you how example 4 will go, you can take off the hat, it's fine. It's just going to be really mad at me when I exit, which is fine. All right, shaded. So here's the trick. If it's shaded between, it's going to be an and. Versus if there's a gap between, it's going to be an or. Gap between means an or. So since there's a gap between, this is going to be an or. So I see here is -2, and this is +2. And the arrow is going that way. And the arrow is going this way. So x is going to be less than 2, and x is going to be, or x is going to be greater than 2. So let's review how we did this. So first, I saw the two numbers. So at -2, the arrow is going to the left, so that's how I know which way the inequality is going, and I have my variable. Because remember, if I have the variable on the left side, the inequality always shows me which way the arrow is going. So working backwards, I have x is less than 2. Or, let's see, on this right side, I see I have a arrow going to the right side of 2, so I have x is greater than 2, so that's my or. So maybe it's helpful if we labeled the point like this is at -6, this one's at 4.
It doesn't matter which one's on which side.
You could say x is greater than 2 or x is less than -2. I just like going in numerical order, smallest to biggest. And by having the variable on the left side, I mean, we can look at the graph and the arrows will show me the inequality. All right, so B, notice there's not an arrow for our left point. It's literally just x is equal to -6 because there's no arrow. Or how would I write this the one on the right? Do we have any idea, Miranda? How would I write the one that's on the right side?
X is no greater than.
Yep, so I see the arrows going that way, so it's going to be greater than 4. Awesome. All right, so this was a gap. So since there was a gap, it was an OR. Josie, about this third one, what type of complex inequality will it be? What kind of compound?
It'll be
And, because it's literally connected. Since it's connected, it'll be an and. I see the two numbers that were centered around is -1 and let's see, 1, 2, 3 at 3. So x is going to be between them, right? So -1 is going to be less than x, which is less than 3. Or you could say x is greater than -1 and x is less than 3. So if you're what?
But X greater than 4.
I forgot to write the negative sign. So if you're struggling with this concept, this is covered on the SAT ALEKS that we're doing. Pick this as your ALEKS topics if this is struggling. Yes?
Isn't one for B is X is greater than X?
Oh, shoot. Yeah, you're right. Sorry. Good job. That's great. You're on it. Okay. Cool. Right, and then I think this is the last couple problems. Example 2. This is a SAT question just thrown in. Just make sure we understand how to do this. If 3x minus 5 equals 22, what is the value of x? How did you get that, Lauren?
Like plus 5, and then I got 27. 27 divided by 3.
Awesome. So we find x equals 9. Cool. So, you know, we're getting there. We're getting there. We're getting it. Solid algebra skills. And then the last two questions. This is just solving and graphing. Do I have 2 volunteers to do? Who hasn't gone today? Let's see. Let's see. Who did the problems? Ruby and Ashton. Lauren or Jesse or Miranda. Do one of you guys want to do it? Yeah, you gonna do this first one? Okay, so I'll put your name here. Who wants to do the second one? Jesse, perfect. Okay, cool. Jane, come up and do it. All right, so Lauren up first, then Jesse. Awesome. It's a good time to stockpile some points.
Don't you divide all of them by -2?
Subtract.
I mean subtract. Oh, subtract.
Yeah, because since it. Oh, sorry.
How do I erase?
Add by -2.
Oh.
3x. 3z minus 2.
How do I erase?
It's just like a normal eraser. Flip it.
Oh, that's so cool.
Yeah. Well, that took me 2 months to figure out.
Mhm.
So since 3z is being subtracted by 2, we can add 2 to all 3 sides. Cool.
And then it becomes negative. Oh. And then it becomes -3. And then you divide by 3 on all of them.
Exactly.
So hard.
I mean, I could zoom in a little bit. I just wanted the.
That cancels out. And z. And then -4 becomes -1. But then don't you?
Well, why are we trying? Why what? -12 is greater than -4.
Oh no.
Oh, I see. You forgot the.
I forgot the, yeah.
So -1 is greater than or equal to z is greater than -4. Awesome.
And then Don't you flip it? So it's
you
like
could.
Z, then -1, and then it's -4.
Awesome. Yeah, and I'll tell you exactly how to graph it.
Mm-hmm. You fill it in, and then this one goes this way. And the -4 is open. So it goes this way, and they overlap over there.
Yeah, so you have to get a different color on the right side and then just fill between them.
Hmm.
So you see how there's all those colors on the very right
Mhm.
side? Yeah, cool.
So just like shade it in here.
Sure. That way it's clear what the solutions are because I'm looking at it and it's hard to read, but yeah, exactly. Cool. So just to reiterate what the solution is, so at -4 is an open circle, at -1 is a closed, and it's literally between them. That is going to be the solution. Cool. So you could shade between them like that. You can have the open circle here and the closed and shade. Either one works. All right, Jesse, we're up. Perfect. Energy? No.
Yes.
It's Friday. Excited for the weekend? Yeah, you don't look it. So my classes, you don't turn in a practice test. It's just for you to help get ready for the day of the test. When is the test?
Is this one from that?
Roughly.
It'll
It'll be pretty close. It's pretty
The
close.
day of the test is.
So do you guys have your lesson?
Oh, yeah, I see. What day is it?
Wednesday. Wednesday. Cool. So you have an extended time. Let's plan on you coming in during lunch, which is right before the test.
Okay.
Wait, how do you? Oh, wait.
On which day?
Wednesday,
Alright.
the day of the test. I'll end the class and then it'll be easier to know. Okay, so they're going opposite ways?
Yeah.
Okay, so you divided, you flipped it, J plus, from -7 goes that way, this way from 3. Perfect. Okay, cool, awesome, yeah, that's the solution. Okay, so I'll end the screencast, don't forget, day of the test, Wednesday for us.